Hello, Synodontist Man here. Welcome to Beyond the Clear Walls, a series covering aquarium fishes from a different angle than what you usually see published and or on the web. That is, I focus on the fish in nature and what makes the fish unique morphologically and taxonomically. Aquarium care coverage, a bit less important here. Today, we talk about the Gyrinocheilidae, a tiny family of fishes that have a less than tiny role in the aquarium hobby. Oh? Have you seen this before? In the year of our Lord 2023, 720p isn't gonna cut it anymore. Here's Featherfin Film's very first video, updated to be more in line with 2020 visual standards, and a lot of new info to boot. The Adhesive Enigma is still adhesive, but less enigmatic. The family Gyrinocheilidae, or algae eaters, is a monogeneric family of fishes in the order Zypreniformes, or carp, minnows, and loaches. It consists of the genus Gyrinocheilus that currently contains 3 species. Gyrinocheilus aymonieri, the quote-unquote Chinese algae eater, Gyrinocheilus pinnaci, the spotted algae eater, and Gyrinocheilus postulosus, or the Borneo algae eater. To most aquarists and 97% of people concerned with this family, aymonieri might as well be the only species. Gyrinocheilids are distributed across Southeast Asia. This is one of the least speciose families in the Zypreniformes, or carp-like fishes, tied with the Violentelidae, a group of loaches. This is significant because Zypreniformes is an extremely rich and diverse taxon. These fishes represent a small, unique group. They are highly adapted to fast-flowing rivers and exhibit several adaptations to remaining stationary. The 3 species of Gyrinocheilidae are distinguished by bodily markings, fin ray counts, and tubercle placement. Gyrinocheilus pinnaci is named after American ornithologist Charles Pinnock, who helped the ichthyologist who discovered the fish, Henry Fowler, acquire several fish specimens. The fish has 10.5 dorsal fin rays and sports spots on all the fins. When young, the body has rows of distinct, separate spots. These fade somewhat as the fish ages and the general body color darkens. Its tubercles are located on the side of its head. The other 2 species have their tubercles on their snout. Gyrinocheilus pinnaci is native to the Mekong River. Gyrinocheilus postulosus is distinguished from its congeners by lacking spots on the fins and having uniform dark body coloration as an adult. Few pictures of very long juveniles are known to exist online, but they apparently have 3 rows of dark spots. A photo was found of a subadult specimen a couple years after the first version of the video, depicting a brown fish with faded markings, a red tail, and brownish fins. Postulosus possesses 9.5 dorsal fin rays and has facial granules that are not tubercles, hence the name postulosus. It's also found in the Mekong River. Gyrinocheilus aymonieri also has 9.5 dorsal fin rays, but only has spots on the dorsal and caudal fins. It possesses 2 rows of alternating spots on the body and the smallest spot directly posterior to the top of the operculum. Don't try to distinguish this fish using other colors and patterns, as they are highly variable and individual fish are very much capable of changing their colors. Like its congeners, Gyrinocheilus aymonieri is also found in the Mekong River, but also extends into the Chao Phraya and Malay Peninsula. Out of these places, only the very tip of the Mekong is in China. This makes its most used common name, the Chinese algae eater, quite misleading. It's named after the French linguist Etienne Aymonieri, who surveyed Khmer ruins in Thailand. A feral population was also established in Puerto Rico, but its current status is rather unknown, especially after Hurricane Irma. But the loaches and the aymonieri are more closely related to each other than they are the Apitanakul, which since the Apitanakul is the most basal of this genus. Quick tangent here. These fishes have literally the worst set of common names I've ever encountered. Algae eater. Thousands of fish species eat algae. That's like calling a horse grass eater. Like the subject of this video, horses indeed mainly feed on grass, but boiling an animal's entire identity down to a diet it shares with thousands of other creatures leads to far too much confusion. In the fish trade, when someone says algae eater, they could be talking about at least 20 different kinds of fish. Sucking loach isn't that much better. These fish are great at sucking, but they aren't truly loaches. To make matters even worse, there's hundreds of actual loaches that do suck, literally. But they're not the subject of this video. In Thailand, one of the native names of these fishes translates to honeysucker. But guess what? There's a related group of fishes called suckers too. Woohoo! Another inaccurate common name. Because the common names positively blow, I'll just refer to the entire group as Gyrinocheilus. It's easier. Here are some features that are found in the Gyrinocheilidae. Their mouth parts are modified into a sucking apparatus. There's a transverse groove present on the tip of the snout. There are no barbels, nor pharyngeal teeth. There's a small slit above the operculum where the fish can breathe from. The swim bladder is small and complete. And there's a bunch of skeletal stuff which I really don't have the time to explain without making the video flow really badly. It's already long enough. Just look at this nice screenshot of stuff I can't explain properly without going way into the weeds. The most distinctive synapomorphy, or a physical feature that defines the clade evolutionarily of the Gyrinocheilidae, is the highly modified mouth that allows them to attach to submerged surfaces in rapidly flowing water. The lips are greatly enlarged and fused together, with their rostral cap, which is a flap of skin above the mouth, used with the upper lip. These lips are lined with inward-facing keratinous hooks with cutting edges that provide friction and aid in scraping edible matter off surfaces, rather like a tadpole. A bit of etymology for you. Gyrinus means tadpole in Greek. Chelos means lips. Gyrinocheilus' family name literally means tadpole lips. These lips are also supported by highly flexible mucochondroid tissue. Mucochondroid tissue is gelatinous connective tissue found in the heads and under the skin of teleosed fishes. The mucochondroid tissue helps support the lips and protect them from pressure-induced damage, a point which will be elaborated upon later. The lips are also fringed with papillae, which are cellular growths made of keratin, around the circumference. The mouth opens in the center of these lips and has two blind cavities directly below it. These are literally organic suction cups that increase the effective area of the oral sucker. When the sucker is not in use, it folds up under the head in two postlabial or behind the lips grooves, reducing drag. The lip margins resemble crescents when the sucker is idle. Suction is produced by the fish widening its lips, pressing its mouth against the surface, and closing the oral valve. Water is expelled from the lips, creating a vacuum not unlike that of, well, the suction cup. The blind cavities below the mouth expand and create a greater area for suction. While the sucker is in use, water is unable to enter the mouth, making it a sucker closed from outside interference. When the fish is feeding, it opens and closes its sucker rapidly against the surface of its choice. This allows the fish to rasp off any encrusting material on the rocks it inhabits. According to an experiment done in Canada in 2006, this type of sucker mouth appears to be much more efficient than the open suckers of lower Korean catfishes. The fish has a greater adhesive strength while using less energy than an open sucker, which operates as the fish breathes. However, the closed sucker only allows the fish to orient themselves in one direction at rest. Lower Korean catfishes can reorient themselves at will, but keep in mind their suction is tied to their breathing, which uses even more energy. My personal anecdotal evidence proves this true, at least the strength part, is Gyrinocheilus always seem to find themselves stuck to the bag when I bring them home, unlike fleckos. Perhaps they come from faster waters than the ancestor of suckermouth catfishes. The suction prowess of many aquatic organisms, including Gyrinocheilus, has inspired the design of underwater biomimetic suction cups meant for submerged robots and the like. Most fishes use their mouths to breathe. Because of their highly specialized oral morphology, Gyrinocheilids have lost this ability, at least when they're stuck to something. When not attached to a surface, however, Gyrinocheilus is perfectly capable of breathing through its mouth like most other fishes. When the fish is using its oral sucker, the fish inhales through a small slit directly above the operculum, or gill cover, that's guarded by a valve. This slit directly opens into the pharynx, or throat, and the water is ejected from the lower half of the operculum when the fish exhales. The slit is narrow, deep, and lined with raker-like structures of unknown function. I'm very unwilling to dissect the two pet Gyrinocheilus I have at the moment, so let's do some classic Featherfin conjecture. Caudillac, there he is again, and Roberts were unsure of their purpose in 1993, and Synodontis Man 30 years later has not seen these structures mentioned elsewhere, unless he overlooked something. If I did, please call me out so I don't mislead the public. The raker-like structures can filter out larger particles, create vortices that direct flow over the gills more efficiently, or provide extra surface area to extract oxygen. This method of breathing allows the fish to breathe and maintain suction simultaneously. However, less oxygen and water flows over the gills than a fish that breathes with its mouth. This may necessitate these raker-like structures. To maximize the amount of water flowing over the gills, Gyrinocheilids breathe more rapidly than other fishes. A feature found in mature Gyrinocheilids is a transverse groove on the tip of the snout. This groove, made of fibrous thickenings of the dermis, which is the layer of skin directly below the visible epidermis, serves as an anchoring point for the supportive buccal-chondroid connective tissue near the lips, and allows for the joint between the maxillae, or upper jaw bones, and neurocranium, which is the brain case and brain case accessories, to move. Since this joint is movable, the fish can use its oral sucker without it getting damaged by excessive force, as the fish hangs on in a current or searches for food. Mature Gyrinocheilids, like many other sopraniform fishes, possess tubercles on their heads. These keratinous growths are present in both sexes of the fish, though they are larger on males. To the uninitiated eye, it makes the fish look like it has the worst case of acne. Both tubercles and acne appear when the animal in question is going through hormonal changes, so it's not the worst comparison. The location of these tubercles is a major diagnostic character for distinguishing the three species. Their purpose is currently unknown. Considering that they're rough and only present on mature specimens, I'll leave you to draw your own conclusions. Staring at race cars all day has led me to come up with some rough ideas in need of some critique. Let's start with the divot that the nasal groove and rest of the head form. This little depression likely lets water flow separate around the fish, which generates drag. In an environment as viscous as water, Low drag is paramount if the organism intends to actively move through it. This problem is exacerbated if the fish comes from flowing water, as the fish has to struggle harder against the current if it doesn't want to get blown downstream. Now, notice the somewhat upright and rounded snout of the Gyrinocheilus. Modern lemon prototypes also have upright yet gently curved finders. If you look directly above one of these race cars, you'll see the mandatory holes in the fenders that ostensibly generate drag. Both the fish and the race car need the fluid to flow around the mandatory drag generating feature. Therefore, both the fish and the race car fenders share a similar shape when viewed from above. This ties into a potential reason for the tubercles to exist on the sides of mature specimens. Recall that golf balls are dimpled and humpback whales have warts on the leading edge of their pectoral fins. These small surface interruptions generate vortices that speed up water flow along the surface, reducing drag. Since these tubercles are on the fish's head, flow downstream is kept better attached to the fish. If the tubercles produce significant drag, however, they could work as a display of mate fitness, as a fish with huge growths on its head, yet still keeping up with the rest of its conspecifics, is obviously very genetically fit. I don't know CFD yet, nor can I 3D model to save my life right now, so no hydrodynamic fish analysis from me with actual figures anytime soon. However, the Canadian study did that for me, and I can report that the drag coefficient of 25 individuals of Gyrinocheilus aymonieri averages out to 0.42, similar to that of a modern truck or SUV. This doesn't tell the whole story, as the coefficient of drag values taken from the fishes range from 0.23 to 0.69. I'll assume that the larger fish were the draggiest ones, as they had more fish to push through the water, plus the odd growths on the fish's face became more prominent at larger sizes. The fish's body also generates lift to the tune of 1.23. As a migratory fish, passive lift generation is rather useful when its body is negatively buoyant. This is a benthic fish that's still capable of swimming strongly. The last comparison between benthic fishes and race car style make for now is downforce. Race cars need to generate more quartering with faster lap times, and a fish may want to stay put on its favorite rock without being swept off to some other rock it doesn't want to be on. Downforce produced by the fluid flowing past the fish helps the race car designer and the fish achieve their goals. Gyrinocheilus has a strong adhesion generating device up front, so it doesn't need to have a highly specialized body shape with huge fins to stay put. A fish like a ballotaurid loach lacks a sucker mouth, so it needs the wing-like fins to help it stay put in the spot it wants. In the racing car world, the closest analog to a sucker mouth I can use are cars that generate downforce with fans like the Chaparral 2J. Since the downforce is generated mechanically, aerodynamic downforce is less important. Enough hypothetical fluid dynamic stuff. That's better suited to a video I made years ago. Noticeably, Gyrinocheilids lack barbels, and less noticeably, pharyngeal teeth, both of which are major diagnostic features of most sopreniforms. Barbels, which are the whiskers on a catfish or carp, serve as sensory organs to help the fish find food. Pharyngeal teeth are located in the fish's throat, on the last couple of gill rakers. They're pretty useful if you swallow things whole, or you don't have teeth in your mouth. The latter is true of every sopreniform. Despite lacking pharyngeal teeth, Gyrinocheilus does possess dermal plates on the gill rakers where pharyngeal teeth would be. Gyrinocheilids probably lack these features because of their diet of encrusting matter on submerged surfaces. They do not have to process their food beyond swallowing or look particularly hard for it. Strangely for a benthic fish at first thought, Gyrinocheilids possess a well-developed, though smallish swim bladder. Swim bladders are organs that fill up with gas to help the fish remain buoyant. Ordinarily, a swim bladder would only hinder a bottom-dwelling fish like Gyrinocheilus in remaining stationary in moving water. Hold that thought! Before I dive more deeply into this fish's relationships, I might need to make mention of Gyrinocheilus' fifth cousins 4 times removed, the Odophysinae. Odophysins are a highly successful, diverse clade of fishes which all share a strange complex of bones called the Weberian apparatus. The Weberian apparatus is located directly behind the neurocranium and the head of the vertebral column, and connects the inner ear and swim bladder. This allows the Odophysan fish to use the swim bladder as an adjunct to their ears, greatly enhancing their hearing capabilities compared to other fishes. Gyrinocheilus has a fairly generalized Weberian apparatus morphology when compared to other sopreniforms. The second and fourth vertebrae are enlarged, forming a shield-shaped structure with little contact with the swim bladder itself. Other sopreniforms with a similar layout are the catostomids and boteids, hinting at Gyrinocheilus' position near the base of the sopreniform family tree. Speaking of vertebrae, Gyrinocheilus possesses a high proportion of abdominal to caudal vertebrae not found in any other sopreniform. Out of 39 to 42 vertebrae per fish, there's 27 to 31 abdominal to 11 to 13 caudal. A higher number of vertebrae oftentimes implies a more basal lineage. Gyrinocheilids have had a long history of being taxonomically unclear. People have struggled throughout the ages to figure out what exactly these fishes are related to. Even to this day, aquarium books and websites don't know where to place these things. They're catfish. No, they're loaches? I don't know, who cares? Let's just put them in miscellaneous. Hold on tight. This is going to get confusing. The first species described, Gyrinocheilus aymonieri, was initially described as a Silurincus, another genus of unclear affiliations in the late 19th century. Silurincus had its own family now, depending on who you talk to. Yay! They're basically small, flattened minnows that live in the Himalayan streams. Congratulations! You now know more than 99% of people about these fishes. By the way, you should really watch the little video I made about them. Back to this video's main subject, the genus Gyrinocheilus was erected in 1902 to describe Gyrinocheilus pustulosus. Gyrinocheilus aymonieri was not very scrupulously described and was placed in Silurincus until 1935. Gyrinocheilidae was also initially considered a subfamily of the Homolotarids, a name which now refers to the modern Ballatoridae, or elongated hillstream loaches. Reagan noticed the well-developed swim bladder and lack of barbels, and realized that this fish was not a member of that family in 1911. However, he placed Gyrinocheilus among the cyprinids. The Gyrinocheilidae was erected in 1923 by Hora. His reasoning was that there seems to be little doubt that, judging from their appearance, the members of the genus Gyrinocheilus are remarkably similar to those of the genera Crocodylus and Gara. But this outward similarity, in my opinion, is directly correlated with the life of these fishes in moderately rapid running waters. The presence of the slender toothless lower pharyngeals, the structure of the scales, the remarkable modification of the gill openings to form inhalant and exhalant apertures, and the structure of the mouth, lips, and jaws are, in my opinion, better defined characters than those that separate Cyprinidae, Cupididae, and Homolotaridae from one another. Gyrinocheilus aymonieri has a couple synonyms to add to the weirdness, which were Bonchadsky and Krasnikovi, but these names were retired in Codlat and Roberts' 1993 paper. To add to the weirdness, Gyrinocheilus pinnaci was initially described as part of another, now invalid genus named Gyrinocheilops. This genus was also used for a quote-unquote Gyrinocheilopsis krasnikovi, which we now know as Gyrinocheilus aymonieri. This is the unscrupulous fish description I just talked about. Gyrinocheilidae itself was erected by Fowler, who used these characters to diagnose it. Eye but little post-median in head length. Pre-dorsal scales very small and crowded. Ventral origins pre-median in length of dorsal base. Caudal deeply emarginate, with rather slender, pointed lobes. Pearl organs of different arrangement and apparently more extensive than those in Gyrinocheilus. Coloration with 2 rows of dark lateral spots mostly opposed. These are obviously very minor characteristics that can be found in individual variation per fish, so the name was abandoned, and for good reason. If you don't have several unused scientific names, or even trying to be a variably patterned brown fish with a widespread distribution in developing countries, by now, I hope we've established that the Gyrinocheilidae is a distinct clade. Where the Gyrinocheilidae are placed in relation to all the other sopraniform fishes is another question. As stated before, Gyrinocheilids have an eclectic grab bag of primitive and derived skeletal characteristics. Many of these are shared with loaches and suckers, while others don't appear outside of this one family. Relatively few are shared with actual cyprinoids. To keep it short, they may or may not be closely related to the suckers, which ironically don't share a native language to them anymore. Or they could be their own clade, either basal to the rest of the sopraniforms, or sister, which means the nearest evolutionary relative, to the Cobbatoidea, or loaches. Relations between the suckers, loaches, Gyrinocheilus, and cyprinoids have not been conclusively resolved. As of Tan and Armbrust 2018, the family has its own suborder. Before the paper that split the Sopranidae into multiple families, the Gyrinocheilus were considered part of the Cobbatoidea, possibly sister to Catastomidae, which in turn were sister to the rest of the Cobbatoidea. So related to the loaches' closest ancestor, if that makes any sense. One of the common names from earlier now makes a tiny bit more sense. There is a video lecture by Hyuk Hui Tan covering the Cobbatoidea that gives Gyrinocheilus a section, so I guess one can call it a loach in a very broad sense. Those other 2 groups are composed of largely benthic riverine fishes, which Gyrinocheilus happens to be one of. Catostomids are sopraniforms that also lack barbels and suck food off the bottom with modified lips. So they were, and still often are, viewed as closely related groups. Some catostomids even somewhat resemble Gyrinocheilus in appearance. However, catostomids have pharyngeal teeth and are unable to adhere to submerged surfaces with their mouths. Furthermore, they breathe like normal fishes. A few recent papers appear to place Gyrinocheilus at the very base of the sopraniform family tree, sister to all the other sopraniforms and in their very own clade. Their conserved diploid karyotype of genome of 48 chromosomes appears to strengthen this hypothesis. According to a Japanese paper published by the Linnaean Society, the lineage leading to the Gyrinocheilidae split off from Sopranidae and Catastomidae roughly 151 million years ago. This data is based off of molecular evidence, as sopraniform fossils are generally fairly rare, and nobody has found any older than the early Eocene. The early sopraniforms themselves only apparently appeared 155 million years ago, around the time Pangaea broke up. However, this molecular evidence was based off of mitochondrial dating, which often leads to overestimation of species divergence times. Yes, the direct ancestors of the algae eaters you can buy at any pet store today might have shared space with the non-avian dinosaurs. Said paper also claimed that the sopraniforms originated in Laurasia, or modern-day East and Southern Asia. Some of the basal representatives of some of the main clades of the order, which are the cyprinids, the loaches, and Gyrinocheilus, are found only in Southern Asia, which is a sign that this lineage originated there. Since many of these clades tend to be bottom-feeding fishes, it's implied that the sopraniform ancestor was indeed a bottom-feeding fish like Gyrinocheilus. The Japanese article also implies that many of the benthic basal saprindiforms competed with each other heavily, leaving some families strangely small compared to others. Remember when I said the suckers don't share a range with Gyrinocheilidae anymore? They are mostly eaten out of house and home by actual cyprinids and fled to North America for the most part. Also notice how tiny and hard to actually place Gyrinocheilidae itself is. The other Gyrinocheilids, if they ever existed, must have had to take on this highly specialized form to avoid the intense competition of the possible saprindiform explosion of the Mesozoic or early Cenozoic. A newer paper seems to again place the group in a clade with the suckers, but this paper appeared to focus more on knifefishes and caracans. This paper also dates the differentiation of saprindiforms around 98.6 to 84.7 million years ago, with Gyrinocheilus and Catastomidae appearing 73.6 to 60.5 million years ago. Still a fairly old lineage, but not putting some dinosaurs to shame. Yet another, more recent journal article places the family as sister to Cobatoidea. Again, it also called out the Japanese paper for overestimating the age of the saprindiforms. For those who still want to mock the dinosaurs with the Indo-Chinese stem saprindiform, the paper still claimed the group arose before the KT extinction event. No matter how you slice it, the Gyrinocheilidae is a fairly basal yet very distinct group within the saprindiforms. Gyrinocheilids are egg-scattering fishes that spawn in the rainy season, which is equivalent to spring and summer for non-tropical people. Their eggs are semi-buoyant, so they can reach the bottom of a different stretch of river than the parents spawn in. Yep, Gyrinocheilids are amazing parents. Just drop their gametes and go about their lives. As arthrophagus fishes, Gyrinocheilus produce many small eggs per fish. A single good-sized female can produce over 80,000 olive-colored eggs during spawning season, allowing the opportunistic fishes swimming by a feast. No word on how many milliliters of milk the males need to fertilize these eggs, however, which is probably a lot. The eggs hatch in about a day, and the larvae start to feed on phytoplankton starting at around 4.5 millimeters long after living off their egg yolk. Strangely enough, the larvae possess a superior or upturned mouth with separate lips until around 14 millimeters long, when Gyrinocheilus' trademark lips develop. The fish begin to scrape algae off of surfaces when they become post-larvae. Juveniles travel together in large groups. In the wild, Gyrinocheilus aymonieri inhabits river basins with hard surfaces they can graze on. Typically, they spend their days in rock crevices. They migrate to floodplains when the water level rises. Pinocchi is known to migrate from December to February or around Chinese New Year time. Gyrinocheilus aymonieri usually feeds on algae and detritus, but is known to occasionally consume small crustaceans and insect larvae. They prefer thinner layers of encrusting matter and defend their patch of algae and slime from any intruders. Stomach contents of mature adults in one study found mostly algae, plant parts, and detritus in 915 specimens. The intestines were also 14.1 times the body's length, indicating a diet that requires a long transit time. All three species grow to a maximum size of slightly less than 30 centimeters or 12 inches standard length. Gyrinocheilids are a food fish in their native range. Tasty. Small ones are used in soup and fish sauce, while larger specimens are sold in local markets like most other foot-long fishes. Judging by their diet and relations, assume they taste like grass and mud with a side of bones. Gyrinocheilus pinocchi and aymonieri catches are important to the local economies of their native range. Since they are less efficient to catch with a hook and line, gill nets and traps are placed in rocky rapid stretches instead. However, there is at least one recorded instance of a fisherman successfully capturing Gyrinocheilus pinocchi with a hook and line. This is notable because the fish is often used as bait itself when it's smaller. You'd think such a highly specialized grazer wouldn't take bait very readily. Luckily for them, they aren't fish with bombs and automatic rifles like other fishes were in the native range at one point. In fact, their populations are declining somewhat because of overexploitation and damming. The effect of damming a population helps these two species as yet to be fully explored, but since these are migratory riverine fishes, it's best to assume the worst. It's known that siltation in the rapids where Pinnacle lives kills the algae they feed on, leading to smaller catches. Despite this, both species are listed as least concern population decreasing by the IUCN. I mean, if you can find the aymonieri at PetSmart for $2.19, they can't be that rare. In fact, the price has dropped to $1.99 since the original video's publishing, making this fish inflation-proof. Little information is known about Gyrinocheilus pustulosis' conservation status, as it has not been evaluated by the IUCN. Outside the native range, the quote-unquote Chinese algae eater Gyrinocheilus aymonieri is an extremely common aquarium fish. It's unknown how they got this name as they rarely occur in China and are much more common in Thailand. Aymonieri is also occasionally known as a siamese algae eater, but that name also applies to another fish, Gyrinocheilus mentioned ever so briefly earlier. Again, see why common names are unideal? Since Gyrinocheilus aymonieri is very easily defined in pet shops, it's a common specimen to use for molecular phylogeny of other fishes, especially other sopreniforms like the aforementioned Gyrinocheilus. After scouring the internet for longer than I care to admit, I finally found concrete proof that Gyrinocheilus aymonieri is indeed bred in mass quantities for the aquarium trade. In fact, there are farms that specialize in breeding this fish exclusively. Therefore, wild Gyrinocheilus aymonieri are rarely encountered in aquarium shops. A paper conveniently released after the original launch of the video details how xanthistic, which means yellow, Gyrinocheilus are bred and raised for export at Ade's Fish Farm in Java. In short, they use hormones sometimes. Broodstock fish are chosen at a size of around 4 inches, which takes them a year or two to reach. Overprim, a hormone, is injected into the broodstock since waiting for the rainy season and changing up the conditions is rather unprofitable when the fish sell for so little money individually. Sometimes, a male and female fish are anesthetized, taken over a receptacle, and squeezed, emptying the fish of its gametes, which are stirred around in said receptacle. The fish must be quite confused when they recover, carrying significantly less mass. AIDS lets the fish spawn naturally after being injected, a process that usually happens at night like in humans. Now here's something y'all won't want to miss: how the females and males are distinguished. Alright, males have pointed pectoral fins, while females have rounded fins and a chunkier body. As far as I know, this bit of information has not been mentioned in any English language aquarium book or website. Back to the eggs. Batches of 5,000 are placed in clean, aerated aquariums medicated with antifungal methylene blue and measuring around 100 centimeters times length, 60 centimeters width, and 50 centimeters height. Aeration is paramount, as the eggs require a decent amount of oxygen to stay alive. This ties into their semi-buoyant nature floating down rivers to reach better hatching grounds. After 12 hours, new life begins as the larvae wriggle free from their eggshells. The yolk is consumed after 3 days, and the fish are fed thrice a day starting on the 4th day of life. As for the fish's first meal, it's a mix of egg yolk and fine bran. Since egg yolk is nutritious and more importantly immobile, so the fish can catch it more easily. The larvae are fed egg yolk until day 18, when they fully switch to pelleted feed. 80% water changes are carried out every other day. After day 18, the larvae can be sold off to other farms to grow out. They're only about an inch long. Adult fish are kept in aerated concrete ponds with a flow-through system measuring around 2 meters times 3 meters times 80 centimeters. Broodstock are fed Fung Lee brand pellets with 30% protein and 7% fat. Values not too far from many commercial algae wafers. Adult fish are given 50% water changes weekly to stave off illness like fin rot. Gyrinocheilus fishes are also occasionally found in fish spas. It serves as a native alternative to Garufa in Thailand. The fish is likely capable of producing a stronger suction, and the golden variant is much more eye-catching than the British brown Garufa. I go into much more detail about these in the Gyrinocheilus video, so watch that if you want my impact on fish spas and their impact on fishes. Gyrinocheilus aymonieri tends to live near the bottom of aquaria, since they are negatively buoyant. Their sucker mouths allow them to climb the walls of an aquarium and attach to any submerged surface. They're also a crepuscular species preferring to be active at dusk, just like the plecos that a few tasteless people find ugly. The other two species are rarely encountered in aquaria, with Gyrinocheilus pustulosus probably never being intentionally imported. Pinnaky comes in very sporadic shipments. They probably behave very similarly, but since they're almost never intentionally imported, only a select few people know, and they aren't telling me anything. First imported to Germany in 1956, Gyrinocheilus aymonieri has been an aquarium staple since around the 1960s. Most aquarium keepers buy Gyrinocheilus aymonieri to try to rid their tank of an algae problem. However, quote-unquote Chinese algae eaters are said to be very poor choices by hobbyists to solve an algae problem. By the way, clearing algae isn't a good reason to buy a fish. Fellow aquarists buy fish because they're cool instead of their potential utility. As young fish, they will apparently eat all the algae and not bother other fish in aquariums. As they age, they supposedly learn to eat fish food, well, they're literally spawned on commercial fish diets, and ignore algae, which is in direct opposition to the wild diet. They can also grow to unmanageable sizes and can be territorial to other fishes in the aquarium, especially other bottom feeders. It's unknown if commercial breeders select for specific traits, besides color, but captive Chinese algae eaters rarely reach their maximum size. They're matured around 4 inches or 10 centimeters anyway. The territoriality can be managed if the owner provides clear floor space and hiding places. Your Gyrinocheilus will have a favorite spot it likes to hide in, and will defend it if needs be. When kept with others of its own kind, Gyrinocheilus aymonieri form the pecking order. This implies that there is a social element to the territorial actions they take towards their tank mates. Considering their eventual adult size, you'll need a large tank to do this in. Similar looking fishes are frequently harassed by aymonieri if kept in cramped quarters together, which is most likely where all the horror stories came from. If one does intend to keep other bottom feeders with Gyrinocheilus aymonieri, make sure that each fish has a place to hide and or they don't look too similar. If so, you may need to crowd the fish like one would Mabuna to curb aggression. Speaking of Mabuna, Gyrinocheilus aymonieri is one of the few fishes capable of dealing with the combativeness, especially larger specimens. Gyrinocheilus are fast, smart, and capable of retaliating. Both types of fishes can even do well on a similar diet of algae and the organisms that live within. The Chinese algae eater will sometimes attach themselves to the sides of slow-moving or flat-sided fishes and feed on its lime coat, causing injury to the other fishes. It's unknown why the fish does this. Nutritional deficiencies perhaps? Bored? Who knows? A plausible explanation for this behavior is that Gyrinocheilus also ingest the encrusting organisms living in algae, and those aren't very common in most fish tanks. The fish needs to get its protein somehow. Fish slime is pretty protein rich, and the fish is in an enclosed environment. What else would a Gyrinocheilus do if it were starving and these annoying fish could swim by its favorite cave? It's unknown if the fish does this in the wild though. Since Gyrinocheilus is especially adapted to marine fish, it would be a good idea to add some extra water flow to their living quarters. As for potential illnesses to worry about, Gyrinocheilus aymonieri has a tendency to swell up. No idea what causes this, but it could be caused by bacterial infections. Overall, care for this fish like a meaner, larger hill stream loach and it should be golden. No pun intended. This time. Commercial breeding has led to the development of albino, golden, piebald, platinum, and short body forms available for sale. Golden and piebald Chinese algae eaters are the most common artificial forms. The rare platinum specimens are highly prized in the native Thailand. Platinum specimens show up in occasional large batches of golden Gyrinocheilus. It's like finding a shiny Pokemon. Whitefish are reportedly good for feng shui when kept among black ones. Speaking of breeding, aymonieri has only been bred once in captivity as far as we know, an entirely accidental occurrence. It involved a drastic change in water conditions, hinting at the fish's migratory lifestyle. 4 fish that were roughly 8 inches long initially lived in a heavily aerated 50-gallon aquarium kept around 76 degrees Fahrenheit. They were moved to a hornwort-choked tank of the same size with water that's warmer and had less water flow. The owner basically forgot the tank existed until they went to do some maintenance and found 7 baby fish. Happily, the babies survived and grew up eating boiled lettuce and whatever food reached the bottom of their aquarium. Despite its drawbacks for most standard community aquaria, Gyrinocheilus aymonieri is still popular enough amongst aquarists and widely sold in pet shops worldwide. Possible reasons for the continued popularity of Gyrinocheilus aymonieri is their low price compared to other fishes, ubiquity, you can seriously find these guys at Walmart back when they sold fish, tolerance for a wide variety of aquarium conditions, and less alien appearance compared to customers because they look like fish and not dinosaurs. Despite the ubiquity in many pet stores, some online shops don't sell these fish, presumably because of their bad reputation. Furthermore, aymonieri's reputation probably keeps the other 2 Gyrinocheilus there in the hobby, by virtue of association. According to data taken in 1997, each individual Chinese algae eater is worth 6 US cents at the time, lower than any other fish in the paper. They also resemble other sopraniform fishes that are sold as algae eaters like Gyrinocheilus, which leads to confusion amongst less experienced aquarists. In the inexperienced aquarist's defense, there's a ton of pencil-shaped grades in the sopraniforms with a horizontal stripe. Some inexperienced aquarium stores even offer them as the adorable miniature lure Tirant autosynchronous, which wild-type Chinese algae eaters kind of resemble when young. More experienced aquarists tend to avoid Chinese algae eaters like the plague, because they don't do their job and have the potential to attack other fish instead. Therefore, Gyrinocheilus aymonieri is one of the few fishes to regularly draw ire from other aquarists. In my opinion, the Chinese algae eater may just be one of the most hated fishes in the hobby. It's not uncommon to see people suggest banning the fish from the hobby altogether, or using them as feeder fish whenever they're brought up. No other aquarium fish has gotten this level of vitriol hurled towards it in my experience. Other aggressive or territorial fishes have a fan base, like African cichlids, which often have brighter coloration or interesting habits. Most other algae eaters stay smaller and have more active behavior. This 1-2 punch means Gyrinocheilus aymonieri has few redeeming qualities in the eyes of some aquarists. This makes it extremely uncommon for someone to set up a tank centered around these fish specifically. Such a beautifully adapted river fish doesn't deserve this treatment. Familiarity may also bring contempt. Because this fish is so common in chain pet shops, you can take its presence for granted. Only the eccentric are going to set up a big river tank for a fish they can readily purchase for $5 at most. As a man that likes his subtly colored, taxonomically interesting bottom dwellers, I couldn't care less about these drawbacks. Why else would I take my time and write about a fish on 3 separate occasions if I did not find it interesting? This is not the treatment such a beautifully adapted fish deserves. To be fair, inexperienced aphorists do keep this fish in inappropriate conditions, and its presence in certain tanks is a canary in a coal mine for worse husbandry errors. The horrific common name also sets this fish up to fail, as just by looking at the name, the fish is already seen as something you just add to a tank for utilitarian purposes instead of being a pet. Fewer accommodations are made for the Gyrinocheilus and its needs, so the fish becomes a nightmare. In their native Thailand, Gyrinocheilus is seen in a much more positive light because invasive plecos are wreaking ecological havoc, and fawn spawn Gyrinocheilus by the thousands, supporting some local economies. They're usually kept as arowana tank cleaners, with the largest ones being especially prized because they are harder to swallow by the arowana. Despite also being seen as tank cleaners there, the large specimens are at least appreciated instead of being taken back to the pet store. Despite how common Gyrinocheilus aymonieri is, information about the fish is actually rather spotty. Spotty to the point that I felt that I didn't adequately cover Gyrinocheilus the first time around. What information I've been able to share in this video is the result of years of observations and scraping books and the internet for hours. Remember, aquarium care is not the primary focus of this series, so it has to come last of all the topics covered. To summarize, make sure that they get adequate space, somewhere to hide, clean water with good flow, and plenty of food. This likely applies to the other 2 species, if by some miracle you come across a specimen. And that's beyond the clear walls Adhesive Enigma's remake. Honestly, Gyrinocheilus aymonieri is one of the most mistreated fish within the aquarium hobby, about a tier below goldfish and betas. I made this video to give it and the other 2 members of the genus their proper due as interesting animals in their own right, not as algae cleaners shoved in 2 small tanks or heavily badmouthed by well-meaning hobbyists. Honestly, who hasn't kept a aymonieri in an aquarium? Have y'all seen the other 2 species in person? Eaten an algae eater? Let me know in the comments. New viewers, you know what to do if you want to hear more about random brown fish and semi-obscure endurance racing cars. There will be plenty more where that came from this year and beyond. This is Synodontis Man signing off. Adios.